what we're going to go over today is what's new with computer networking. Now, probably there are items here that you're familiar with, but some maybe might surprise you. And so without further ado, I'll just mention, if you have any questions, put them in the chat box and we'll go through your questions at the end of the presentation, if that's okay. And I'd be delighted to get feedback from you as well. As always, we'll make the presentation available in PDF format in English and Spanish. That will be available on the Flytec website, and also we'll have a recording, a video recording of this ready to put on the website. Let me just check that the video recording is on. Yes, we are recording, so that's good. Let me go back to share the screen. So welcome everyone. It's a pleasure to see you all here. And let's get started with the presentation. So what's new with computer networking? I divided this into 4 sections. First of all, a brief introduction to network technology. What are the advances with current technologies that we have? What about new emerging technologies? I think there'll be some surprises here for you. And then finally, product and software development. As always, a lot of the products we talk about are available from Flytec Computers. So what are the objectives with networking technology? What direction is it taking us? Well, we know for business business networks, we're always looking for speed, faster LAN speed, faster WAN speed, LAN over copper cables, and WAN over fiber cables. We're looking to improve the reliability with maybe dual WAN, load balance. We're looking to have greater WAN traffic because we're moving a lot of applications to the cloud, and so that's very important for us. We're looking for much better protection against cyber attacks because ransomware has become a scourge. Failure monitoring and alerting, and hopefully with automatic repair, so that when something fails, we have an automatic recovery. And then ease of use for outsource management and support tools that help our outsource providers, our IT providers manage networks for their business customers. Home networks, we have a simpler list of objectives. We just want a fast connection to the internet, have fiber to the home if available. If not, then at least fixed wireless access, 5G wireless. And if that's not available, then what we have remaining is low Earth orbit satellites such as Starlink. And we would like as well mobile integration with roaming when we travel, so that if we have our network configuration set up, then we'd like to continue to use that network configuration as we travel, go to hotels, that type of thing. So what drives this demand for networking technology? It's a process called digital transformation. And this process is occurring in all types of businesses. There may be a few businesses left that rely on the horse and cart, but the rest of us have to use technology to do business. And we have a situation now where all aspects of business operations have some IT component. Businesses have to become global as well. We're not just selling to Miami or selling to Florida. No, we're selling to the whole world. We're shipping everywhere, and we have logistics issues. We're automating manual processes. We're moving applications to the cloud for efficiency. We have business models today which are not possible without technology, especially, for example, online selling, e-commerce. We also see that this new AI, if you're a user of ChatGPT, it seems like the silver bullet. Well, not quite. For those of us who've used ChatGPT, it's okay to produce a few talking points, but the information is a little bit old and we have to edit it. And also ChatGPT comes up with a few errors that we have to sort through. So it's not exactly ready for full-time business yet. And finally, IT is a competitive differentiator for many businesses. You know, the better IT we have, the more competitive we are in the market. And so what are the consequences of digital transformation? Well, technology is becoming too complex, and so we have to rely on experts outside the company to help us with that. There's an increased risk of cyber attacks. The more technology we have in the network, the easier it might be for hackers to access our network and plant ransomware. Also, competitive pressures on every business in order to stay one step ahead. Now, I prepared a list of 18 subjects for the current net technology status, and I'll go through these, ranging from number 1, which is network device addressing, up to number 18, next generation hotspot, and everything in between. You might think, well, there's something I missed out, but I've tried to be comprehensive within the time available. We're all familiar, I think, with network addressing, where we should have switched from IPv4 to IPv6 about 10 years ago, because that's when IPv4 IP addresses ran out. We know that there's a big difference in the range. IPv4 was 2 to the power 32 unique addresses, and IPv6 is 2 to the power 128 unique addresses. We know that if we're configuring routers or any type of network device, we're going to give that device an IPv4 address and an IPv6 address. And we know that if we're connecting to the networks, our WAN network may not even have a public IPv4. It may only have a public IPv6. And the IPv4 address we have is a private subnet, what they call carrier grade NAT. So we often don't have access to a public IPv4 anymore. The IPv6 is a tool that is very advantageous, because any business can request a block of IPv6 addresses, and we can set up a device-to-device communications between networks in 2 different locations, which is an extremely powerful tool for us to build and customize data networks. So that's one thing to keep in mind. Another area that I mentioned, cybersecurity. We have a technology that's becoming very important called zero trust cybersecurity. We have the scourge of ransomware, where the thieves are trying to hack into our networks. And so what we do is to ensure that we trust anyone who's connecting to our networks. And if we don't authenticate them, they don't get connected. And we do this through an endpoint firewall. And so any device, any user that wants to connect to the network has to go through a process of authentication. We're going to set up filtering rules. We're going to determine what that device can access and what is going to be blocked for that device. Okay. We're going to monitor that device and generate reports so that we see what that device is doing. And zero trust security actually has the ability to, if we configure it correctly, we can block even an attempt for a hacker to plant ransomware. So it's a very, very powerful tool. It does obviously require imposing restrictions on the network, but those are worth it. The users may not think so because they have extra work to do to connect to the network, but certainly the person who is in line to pay the ransomware will appreciate it a lot. Multi-factor authentication is also very important as a tool for authentication of users. We all use this because if we want to access our bank accounts, we have to use this. If we have an Amazon account or any other type of account, we have to use multi-factor authentication. In most cases, it's two-factor authentication, whereby we have a username and a password, which is something that we know. And then we receive a one-time password on our phones, which is maybe a 6-digit number, which is something that we have. So even if a hacker is able to steal our password, that person will not get access to the network because the network requires also a one-time password. We can make this 3-factor authentication if we're going to also authenticate the device that the user is connecting with. And so we can set up parameters to authenticate that device. And that becomes 3-factor authentication, which is stronger than 2-factor authentication. And so this is something which will become ubiquitous. If we want to connect to any type of network, then we're going to have to provide a one-time password to get access. And we'll get used to it. We are already used to it logging into our bank accounts now. We have new cybersecurity tools which use artificial intelligence. And these are already in use by some of the big companies like Google and many banks. What we do here, we have an appliance in the network which is gathering data, and we're looking for anomalies. We're looking for situations where a user workstation starts doing something that it's never done in the past. And so we basically feed that information into a neural network and look for pointers that tell us that something unusual has happened, and then we can investigate or maybe even disable that computer. This is today an expensive tool. The big companies can afford it because maybe it runs into the hundreds of thousands of dollars a year because you have to install an appliance, which might be a Cisco router. But then you have software running in the cloud, artificial intelligence software, which is gathering this data and making an ongoing analysis and alerting the IT people if there's any problem. But it's a software that provides good results. A lot of companies rely on this today. The problem is it's too expensive for small and medium companies, but the prices will fall for these products, and eventually we'll have maybe $1,000 product or $2,000 product for installation in a small company. IP telephony, another area which you're familiar with. We've all been using IP telephony apps for a long time, Skype and WhatsApp, that type of thing. What we are seeing is that our dial-up telephone line is an endangered species. It's disappearing very quickly. We're connecting our phones over the IP network. And today, if you want to buy a dial-up phone, I doubt that anyone is selling it. Everyone is selling IP phones. And IP phones, of course, provide a lot more resources for us. They're much more powerful. And we can either put a PBX in our local network, or we can use a cloud-based PPX over a SIP trunking network. So the telephone companies knew what was happening, and so they all offer these services, but they're a little bit expensive. There are a lot of independent vendors who offer IP phone services that are much cheaper. Last mile data connection. It used to be that we had a DSL connection for many years, which really didn't give us very good performance. It operated over short distances, so people in rural areas couldn't get a DSL connection. And the only option was geostationary satellite connections for rural areas. Well, that has changed a lot. The government nearly 2 years ago put 45 billion on the table for businesses that wanted to install fiber, and so there's been effectively a fiber gold rush. where many companies are installing fiber, and especially to urban areas where the payback is pretty fast for fiber. Not so much in rural areas where there are maybe physical obstacles that prevent you installing fiber, or the ROI, return on investment. The cost is so high that you'll never recover that installation cost. And so obviously optical fiber is the choice that we would make if we could make that choice. If we can't get optical fiber, and that's a gigabit speed typically, we can go to FWA over 5G. Companies like T-Mobile, AT&T are offering that, which will give us maybe data speeds of 250 megabits. And then if we can't get that, low Earth orbit satellites like Starlink, which gives us a speed of about 100 megabits. And we also have WISPs who offer point-to-point connections, and that can be up to a gigabit in speed as well. One thing we know that a lot of the wireless internet service providers got the government money and started connecting their customers using fiber, and so they've become fiber ISPs. Private 5G networks. Now, I'm sure you're all familiar with 5G networks. The carriers upgrade it to 5G, but there are also many businesses that are installing private 5G networks, and this is especially the case where Wi-Fi technology is not adequate for the application that businesses want. There are many use cases for this. I listed a few down there: oil rigs, hospitals, metropolitan areas, industrial plants. Basically, 5G has advantages over Wi-Fi. It's got a much longer range, a better signal. It's got faster data rates, better encoding, better encryption. And so it's also more secure, and you can connect a Wi-Fi device into a LAN network. You can integrate them seamlessly. Now, the way, obviously, 5G networks are not unlicensed like Wi-Fi. So the businesses that install these either make a partnership with a telco that owns spectrum and will release the spectrum to them, or else there's a band called CBRS, where a company can purchase a license to work on the CBRS band. And so this is something now, especially with the cost of the 5G equipment coming down, obviously much more expensive than Wi-Fi, but it's a lower cost, and companies can afford this and take advantage of it. 10 gigabit LANs, I'm sure some of you have used 10 gigabit LANs. They're pretty common. We can have 10 gigabit switches, 10 gigabit interfaces for our computers. This is especially important in the data center, where we need fast communications between servers. A lot of servers can operate at 10 gigabits. Typically, a server is a dual Xeon CPU, maybe 20 cores or more. And so these are very high performance devices that can communicate over the network at very high speeds. And so we may want to expand some areas of our company using 10 gigabit also, and that will maybe be an advantage to do that in special cases. The only difference between 1 gigabit and 10 gigabit is the cost, where 10 gigabit is obviously more expensive than 1 gigabit circuits. Wi-Fi 6 is a standard that's been with us for a couple of years. 802.11ax. It's an excellent standard, offers much better performance. We can go up to 9 gigabits on the Wi-Fi 6E. We've got another band, which is the Wi-Fi 6E, 6 gigahertz band, which has more bandwidth. We can work at higher data rates. And also, very important, we've got a much higher density. We can have many more people connected to our wireless access points, and you'll appreciate that if you've been in an international airport like Miami trying to connect to the Wi-Fi. It really is not built for that density, that many people. And so Wi-Fi 6 is going to be a great benefit to the locations where you have many people trying to access the Wi-Fi. So I really hope the international airports get upgraded soon. These are products that are off the shelf, very reasonably priced, and any business today can upgrade to Wi-Fi 6 products. Wireless antenna technology is an area that really hasn't evolved. You know, the average Wi-Fi unit with the little antenna sticking up, that's 100-year-old technology, and really we can do much better than that. That what limits the distance, basically. You know, Wi-Fi with a decent antenna can communicate at 30 miles distance. Unfortunately, with the little antennas that we put on these devices, it can communicate maybe 200 feet or 300 feet, very limited. Now there are various types of antenna technologies, and they come under the category of smart antenna, but they may use beamforming, phase array, adaptive array. There are differences between the technologies that manufacturers implement. Basically, we put multiple technologies on a surface and we change the phase of the antenna transmission in order to direct the beam. And this is how the Starlink antenna works. That's why it's expensive. The Starlink antenna has a visibility of 180 degrees from horizon to horizon and can track satellites as they move across the sky and can communicate up to 300 miles, and all with the same power that the Wi-Fi uses. And so you can see that antenna technology can be improved considerably. So you can have Wi-Fi installations that communicate over longer distances, much longer distances. There are some products out there, Ruckus Beamflex, Cambium beamforming antenna. So any WISP, for example, that's setting up a point-to-multipoint antenna might consider using a smart antenna device in order to communicate over a longer distance. Network connected IoT devices, Internet of Things. These are all around us and we don't really know. I listed some applications there: home office automation, agriculture, highway traffic management, healthcare, hospitality, maintenance. When we go to a hotel today, we'll probably have one or more IoT devices in the hotel room. We'll probably have an IoT device that's managing the AC, so that when we go out of the room, it turns the AC from a low to a higher temperature, saving electricity, saving the hotel money. It might provide an app so that we can control the AC on our mobile phones. One of the big problems with IoT devices is they have very poor security. They're basic computers, microprocessors on a circuit board. They do not have secure software, and so they're the point of entry when attackers want to get access to a network. And so we have to be very careful if we're adding IoT devices to our network, because a lot of them are connected to the internet. So they're connected to our networks, connected to the internet. We do not want to give the cyber criminal an easy way to get into our networks. And so we have to be very, very careful when we're installing IoT devices. Software-defined networking is another area where larger companies are investing a lot of money, and with reason, because a lot of the corporate data processing systems are migrating to clouds, and it's not one cloud, it's several clouds. We can put the business applications in a company cloud. We can use software as a service, for example, Office 365. We can put some of our applications into clouds like Amazon or Azure. And we have many different locations in our network. Maybe the company has global operations. And so it wants to optimize the network connections. Now we have TCP IP networks, which are the lowest cost method of connection, but often not the most reliable. We can have MPLS, multi-protocol label switch networks, which are much more reliable, much more efficient, but have a much higher cost. And so we can determine how many connections we have to TCP IP networks and how many to MPLS networks, and we can switch traffic between TCP IP and MPLS. And so it gives us a lot of flexibility to manage the performance of the network. And so if you're a large corporation, then you need that type of flexibility. Cisco are the leader here. They have the best products for software-defined networking. Open technology mobile networks. There's the mobile networks that we all use, the 5G towers. The telcos have been pushing for several years to reduce the cost. Firms like Nokia and Ericsson basically had a monopoly on this market. They build the towers, and so once a telco installs a Nokia tower, all the other towers have to be Nokia as well in order to be able to manage the network. Or if they go with Ericsson, the rest has to be Ericsson. The telcos did not like this. They pay much more than they believe is necessary. They can't switch vendors. And so they've pushed for an open RAN, or we call it an open radio access network topology, whereby the mobile network is divided into modules, and many smaller companies can build modules, and these modules can be connected together. So now some of the 5G networks use Open RAN technology, and in future, the tendency will be to incorporate more Open RAN technology components. Even Nokia and Ericsson they've moved to Open RAN as well because they had to. If you want to find out more, there's a couple of very good websites, the oran.org, the ORAN Alliance, and also telecominfraproject.com. So check them out, very interesting. Multi-SSID wireless networks, LAN networks, partitioned subnetworks using VLANs makes a business network much more secure. We can ensure that the secure parts of our network can only be accessed by those who are authorized, and less secure parts of our network, maybe we're not authenticating the users there too carefully. This particular diagram is an example for hospitality, whereby we can set up one wireless LAN network, which has two SSIDs, one for guests and one for staff. The encrypted one for guests will connect to the login page in the gateway and be firewalled from the back office network, whereas the staff will connect through the gateway to the back office network to access applications. And so this type of technology provides a lot of advantages for many businesses. Internet service provider automation. One of the problems that WISPs and small ISPs have is a difficulty in competing with the larger ISPs. It used to be that WISPs were the only businesses providing wireless connections to customers, but now companies like T-Mobile, AT&T are providing fixed wireless access, and they're providing it at maybe $50 a month. And so WISPs are having to rethink the way they deliver services to their customers in order to get their cost right down so they can remain competitive, because in the past they haven't had to worry too much about being competitive. And so now there are tools like EasyWisp which reduce the cost per subscriber of managing those subscribers down from maybe $1.50 to 20 cents a month or 10 cents a month. And so these technologies are going to be advantageous to the small businesses providing internet services. Improving network reliability is another issue. In the past, we haven't been able to have options like dual WAN, whereby we can double our bandwidth and have failover if one circuit fails, because we haven't had the option of having a second circuit. It's we've had maybe DSL and that's it. Now we have many more options. We can have a fiber connection. And we can also have a 5G connection. So we can have the fiber as the primary connection, of 5G as a secondary. We can sum the throughput of the two circuits, but if one circuit fails, then we fail over to the other circuit. So that gives us much more reliability. And that's essential now, because we're moving our applications to the cloud. So if we lose the WAN circuit, then our business stops. And so any business which moves applications to the cloud has to implement dual WAN. It's an obligation. If you don't have that, then that's the weakest link in your network. So they have to move to that. There are many good products like PepLink, multi-WAN routers. You can have several WAN circuits. And so is something that our businesses have to move towards. Network failure monitoring also it's essential to automate failure monitoring. I'll give you an example. If you have a business with several wireless access points and one of them fails, you don't know that it's failed. Why? The only thing you know is that maybe some of the user computers are slow. Why? Because they're connecting to a different wireless access point with more people connecting to a wireless access point, longer distance, poorer quality signal. And so the performance is slow. We have to monitor these devices. And today it's very easy because all the devices that we buy have SNMP agents. And so we just install an SNMP host, configure it to monitor the devices and send us an alert if a failure occurs. And a lot of service providers do this, but businesses have to request this and ensure that this is done. Next generation Wi-Fi. If you're familiar with 802.11u, this is a cellular Wi-Fi standard, and this allows us to create mobile broadband networks. So we can set up antenna towers in various locations, say through a municipality. Each antenna tower can be connected to a different ISP, for example. But our customer can connect to one of the antenna towers, and then as that customer moves through the city, switches from one tower to the next and stays connected to the internet. And that's exactly the same as a mobile network, a mobile phone network. And so this technology is coming to Wi-Fi, and there are products like Guest Internet that have this available today. And there are companies, especially in South America, that are using this for municipal networks. Okay, what about future network products? That's I think enough about the technologies that we have today. I've got 7 points here, which I'll finish off with those 7 points that will make our lives better, we hope. Okay, the first one is Wi-Fi 7. It's not available yet, but it's promising to give us much higher data speeds and much higher data density, up to 46 gigabits. And so we expect to see this in the market, maybe have the odd products later this year, but the standard 802.11b will not be ratified until next year. And so it's only really after next year that we can think about installing products, because if we buy a product today, Wi-Fi 7, it may not be compatible with the final standard. So that's something to look forward to. 100 gigabit fiber WANs, well, that technology is available today. It's only available in a few locations, though. The fiber is the same as the 10 gigabit by 1 gigabit fiber. What changes is the equipment on the endpoints. And so 100 gigabit fiber is available maybe in some few locations. If a business needs 100 gigabit, then maybe the business has to move to get that 100 gigabits. This will become much more ubiquitous. Many more ISPs will be offering 100 gigabit fiber connections. 100 gigabit LAN networks, well, that's here, and we can install them. The only thing is copper is a bit limiting for 100 gigabit networks. Up to 10 gigabits, it works fine. But 100 gigabits, we're looking at maybe fiber connections in our LAN networks to connect our servers, our data centers. Next generation cybersecurity. I mentioned a few technologies We need a firewall for our network. We need an endpoint security device to authenticate our customers for to protect the network, and maybe endpoint plus AI so that we track what people are doing. And we implement a zero trust network, and we also have encrypted remote connection. So we can package this all in one product, and we probably will see this package. The large corporations can buy these products today. Obviously, small businesses can buy a firewall also, but the endpoint security devices and AI devices are mostly quite expensive and cloud managed. The Ethernet product is going to be a much lower cost endpoint security device for small businesses, but the tendency will be to package all these into one security box, like the one I'm showing you there, next generation security appliance, in order to ensure that we have much better protection against hackers. And so the cyber criminals are going to struggle once we have this technology implemented in networks. And hopefully that next generation security appliance is within the purchasing powers of small businesses. Maybe it's $1,000 box, which is basically the price of a PC. And so if it's in that ballpark of cost, $1,000, $2,000, then it's within the reach of small businesses to protect themselves. Mobile 5G to satellite. There have been some tests which have been very successful. Companies like AST Space Mobile have put these huge satellites into orbit. Once again, they use the smart antenna technology, the phase array technology. And so it's basically a 5G phone tower in the sky. And so our terrestrial phones can communicate with the satellite in order to connect us to a 5G network, which is an extremely valuable asset. A lot of locations in the world, most parts of the world don't have 5G towers. And so it allows us to increase 5G phone coverage. 6G mobile networks. This is in the planning stage right now. There are no products for this, but we're looking to get data rates up to 11 gigabits. The 6G will be using higher frequencies. It won't use the same frequencies that 5G and 4G we use. It will use higher frequencies that have a much bigger bandwidth in order to get the higher data rates, but be managed with the same thing. So this will be an extension to 5G circuit, 5G types of service in order to provide a faster data rate for those people who need it, probably a FWA type service. Expanding fixed wireless access. Well, around the world, there are many 4G LTE networks that the telcos are not upgrading because it costs a lot of money to do that. You know, the big telcos here, like AT&T, have spent tens of billions upgrading their networks to 5G. A lot of telcos around the world don't have that money. Maybe the telcos in Europe do, but in other parts of the world, they don't have that money. They have maybe 4G LTE networks that reach their capacity because the telephone service is limiting the availability of data connections. And so there's no capacity left for fixed wireless access, FWA. What some of the telcos are doing is increasing the capacity to the tower. They maybe have a fiber to the tower that was 100 megabit. You can up that to a gigabit with just by changing the devices at each end of the fiber. And then they put a broadband access gateway at the tower, because one of the problems of adding more FWA customers is that you're going to have to upgrade a central broadband access gateway and upgrade your billing system. Well, with this method, you can use the same billing system and you don't change the central broadband access gateway. You put one at the tower, a smaller one. And so you install 4G LTE antennas at the tower, operating over licensed bands, or even ISM. Non-licensed products, and then connect those back. You manage the customers with the same billing network, same billing system, but you're able to get much more capacity from an existing infrastructure for a very low investment cost. And so this is something that a lot of telcos are doing. Telcos outside the USA are doing this in order to be able to service more customers, especially FWA customers. Okay, future benefits from evolution. Well, they're what we expected: faster data networks, improved data network security, and improved reliability, especially today when we're moving applications to the cloud, and we can't rely on the ISPs having 100% connection. Let's talk about a few of the products that are available to implement what we're talking about. Products for IP telephony. There are many different types of telephone products available. These are some that Flytec have. You can put a PBX in your local network, or you can use a cloud-based PBX with the SIP trunking connector. And many businesses already have this. There's still a lot of businesses with the old AT&T phones, which cost an arm and a leg, and you really need to upgrade. And so this big business for IT service companies now upgrading the phone systems in businesses. Wi-Fi 6 products are available from many different manufacturers. Here we've got Ubiquiti, Vilo, and HP. All great products with great performance, and there's no reason why a business should not upgrade to Wi-Fi 6 and get the benefits of Wi-Fi 6. As I said, we're looking at improving the reliability of our WAN connections using maybe dual WAN routers in order to share the load over 2 WAN circuits. One of the WAN circuits is probably going to be a 5G fixed wireless access, and so we need a modem for that, and there are many different 5G modem products or 4G LTE modem products. Here's an example of some of them, and basically you need to get a SIM card from the vendor, put an antenna on the roof, and you connect up your second ISP circuit over the 5G network, and this gives you good performance. It's a great way of ensuring reliability of a business network to those cloud applications. ISP subscriber management, I mentioned products like EasyWisp will reduce the cost dramatically for an ISP or a WISP in order for them to be able to compete with the telcos that are getting into fixed wireless access. Cybersecurity products, firewalls like that from WatchGuard, Orthonet, endpoint security products to implement zero trust applications, specialist guest internet firewall for hospitality to protect the business network when you provide internet for the public. And then products to build segmented networks with VLAN isolation. You've got Ubiquiti, you've got switches, routers like that from Microtech, and then specialty products like the guest internet, where you can set up dual wireless networks for guests and staff, which are much easier to configure, but limited in scope. Finally, a quick word about internet technology answers. We have several different categories of consulting services. Internet services include mobile broadband technologies, management of services for mobile devices, fixed broadband technology, fixed wireless access. We can help companies with that. And then cybersecurity consulting, where we can go from a business infrastructure risk assessment towards employee training and compliance with standards. And finally, where's my mouse? That comes to the end of this presentation. I've gone a little bit over time. I apologize for that, but I'm ready to take your questions.